Yeah. So guys, what I want to edit for our previous project is adding just topologies, and I must change uh, this customer. It should not be a polygon. It is a table actually, because we do have data for this customer. So it should be a table, an object, not a polygon. So here I'm adding topologies for lines, points, yeah, things like this. So for every point, for example, uh, a point should be disjoint. So for example, here I have a point. I want to define a topology uh, from this point in relation to the same point. So I will add, as you can see, I opened the topology here. I must add every entity or every feature or every table that uh, that is is playing a role in this topology. So I've just picked all the features, all the concerned features, and I drag them here in topology. Yeah. So for this, I can take a, let's say, point here, gas meter. I take gas meter and I drag it here. So I will import it like a link, so it appears here. It will appear with the relation with other features. Yeah, you can see that here it appears with the relation with the house pipe. So I want to define a topology for this one here. I will choose topology rule from this point to itself. So you have now this point here. Yeah. So I will double click on the topology. I'm sorry. Double click on the topology. I give the name. Okay. I say gas meter should be disjoint. Okay. Then if I go in tags, I will see here in topology rules, I will see point. There must be point disjoint here. Wait, I'm looking for it. Okay, point. Okay, point disjoint. So I choose this topology rule and I click on OK. Yeah, I do the same for all points. For polygon, for example, I've fixed this topology here. It should not overlap, so we can't have one polygon station, control station, and another one which overlaps the first one. We can't have this. Another thing that a polygon must be closed. It means we can't have gaps for a polygon. So I have to define again the topology here. Okay, for this polygon. Okay, so I will click on topology rule uh, from this polygon to itself. Okay, let me put it here. Sorry. For example, here I double click on it. The name is control station. Control station should not have gaps. And here I want to choose now the topology rule. The topology rule here it is, yeah, so the area should not have gaps. Okay, so I choose area no gaps and I click on OK. So um, we have also some relationship, for example, between line, yeah, between lines and polygon. Okay, if you define a topology between, for example, high pressure, okay, high pressure main and the control station, there must be a topology here. For example, this line here must be connected to the control station. Yeah, okay. It must be connected to the control station. So we have to define this topology. For this, I will click on topology rule, okay, from this point, this high pressure to control station, which is a polygon. But you must pay attention because the topology rule will sometimes coincide with the what we have here. It is the relationship. I drag it here, then I can give the name to the topology, double click to the topology. So high pressure main, should end in control station. Yeah, so I come here and I choose for line. This is line should end. Okay, this is the line. Okay, now here you have to read which one, yeah, which one fits better to the topology you want to define. Yeah, so this one is line covered by line class. Okay, so you have line covered by area boundary. You have line endpoint covered by point. Okay, okay, we have line inside area. So I will choose this kind of topology because I want uh, my uh, my high pressure to be always inside. Yeah, I want the end point of the line to be covered by a polygon. Yeah, that's what I want. Okay, that's what I want. Yeah, yes, have to look for line endpoint. covered by polygon, yeah, or by area. Okay, this is what I'm looking for. Area boundary covered by area boundary covered by area boundary. Yeah. Okay. Yeah, this is for point. Sorry. Yeah, so here we should have like a topology which says that the line, the end point of the line, uh, is covered by the control station area. We should have the topology like this, but we don't have it here. So we can do a combination of topologies. For example, we can create a point. Okay, we create a point here and we define the topology with this polygon, saying that this point, okay, this abstract point here should be covered by this polygon. Okay, so we connect. It means we create an abstract point at the end of this, at the end of the polygon. Okay, then we will establish a topology rule between the abstract point and the polyline here, the high pressure main, saying that the end of this high pressure main should be, now we consider this one covered by a point. So we combine two topologies to form the one we are looking for, because we don't have it here. We don't have the endpoint of a line. The line endpoint is covered by area or boundary of an area. We don't have it. We only have line covered by area. This one is not what we are looking for. Okay. So the idea is to create a point here. Let's say we create a point. Okay. In this topology, we can call it point on control station boundary. Okay. So you can write here in description, you write that this point is used to create a topology rule between high pressure main and control station, because the topology rule uh, line endpoint covered by area boundary does not exist. Okay, in the given list. So we create like a composite, we create like a composite topology rule. Okay, so we will have the topology rule from high pressure to this point here, and we will have a topology rule from uh, this point to our control station. Okay, yeah, we can do it like this. So this topology rule here, the point is located on the control station boundary. Okay. So here we define the topology. It is a point. Okay, it is a point. So point covered by area boundary. Okay, okay, yeah, okay, yeah. So we have a point covered by area boundary. We can define this topology. Then we define this one here. Okay, and we say that this topology now is end line, so line endpoint covered by a point. Okay, so here the endpoint of high pressure should coincide with a point on control station boundary. Okay, yeah, and like this we have defined the topology, the complex topology. Yeah, so this is how we define topology with so we define topology uh, here in Enterprise Architect. Okay, yeah, you can, so we can continue defining the other topologies. For example, for this point, disjunct. Okay, yeah, that is our end node. This one is start node. Okay, I will write here start node. So here it is end node, and the topology is point disjunct. Yeah, you can define the other topologies. For example, uh, there is a topology between let's say, for example, the end point, the end node should coincide with the main segment. Okay, it should coincide with the main segment. The same for start node. The start node should coincide with supply main and uh, with uh, with supply main segment. So we have to define this kind of topologies. For example, this one, okay, we define it here, and here is the topology. So supply main, this is supply main should end in start node. Okay, then here we will define the topology. Let's say line endpoint covered by point. Okay, we do the same for this topology here. Okay, because this is a line, so we define a topology. So supply main segment should start in the start node. In the start node. Then here it will be also line endpoint covered by, but it is not here, it is not endpoint. Okay, it is not endpoint of the line. Yeah, yes. So we are going to define this topology here. I delete it. I create another one from this start node to uh, supply main segment. So it will be the start node should coincide, okay, with start point, okay, of supply main segment. And here I choose the topology rule, point covered by line, point covered by, there must be here a point covered by line, okay, yeah, again here we have to create a point which starts to the supply main segment, and then we use this topology between start node and the abstract point we have created. Yeah, anyway, so this is how we create topologies here. Okay, this is how we create topologies here. You can try to create other topologies. Yeah, and yeah, this. Okay, so I think I'm done with topologies. These are sufficient. Okay, you can create more topologies. Yes, so it is making our geodatabase really complex, very, very complex. And here you should go in, yeah, now you can see the topologies that we have defined. Yeah, yeah, the other one thing I have to do is to change this one, to change it um, to table. Okay, I would like to change it to table. For this reason, don't know if in advanced we can change it. No, don't think. So let me create a table object class. Yeah, I give the name customer. Customer. Okay. I would like to see if it is possible to copy all these attribute. Now it is not possible. Copy as new. No, it is not possible. So I have to create all these. Yeah, but I should write them exactly in the same way. For example, here I have build type, yeah. This is build type, billing type, okay. Yeah. This is customer ID. Customer ID. It is a string. This is date of contract. I will change the type after. This is house number. House number. Okay. House number. This is meta ID, foreigner key. Then this is name of customer. This is street customer. Street customer. Okay. This is tariff. Okay, so I want to have a look at all these. So starting on this one, this meta ID, it's a string. Okay, so I will edit the length of this string, and yesterday we decided to fix it to 100. Okay, this one is also a string. Okay, 100. Okay, house number we fixed it to integer, so I choose here integer, and I define the precision. Yesterday we fixed it to 9. Okay, yeah, the precision must be between 0 and 9. Yeah. Date, this one is a date. Customer ID is a string. Okay, street customer we defined it as a string. Tariff, we used a domain, so you click on select type and you will go and choose the domain tariff. Okay, as well as billing type, we choose billing type. Yesterday we created domains and so on. Yeah, so I click on close. So hopefully I have all attributes here. Yeah, then this relation I will take it, and I want now to so I will take this relation here to I want to change the relation. Okay, so I can do it, because if I double click on here, I see that the source is gas meter and it goes to customer. Okay, so I will select relationship class from gas meter to customer. Yeah, we named it linked to. The rule 1-to-1. For the rule, multiplicity was 1-to-1, and we gave the name here, display in. Yeah, here it is. It should be now display for the customer, and here the customer will be reading or reads on the gas meter. Yeah, I click on OK. I get rid of this. Hopefully I can. Yeah, I can't. Wait. I want to take this line. Yeah, okay. Yeah, it is good. I'll delete this. Convert this line to yeah. So here we are just doing design to sorry. Yeah, we are just making design to make some text readable. Yeah, this one also is so good. So I can change the color as I want. Let's say this one. Okay. Okay. So done. Yeah. Now what I want to do is once more I will validate, and after I've validated and fixed all errors and warnings, then I can uh, export my export to ArcGIS workspace XML. Then I can go and create a geodatabase in ArcGIS Pro. Then I will import the XML document. Yeah, it will read all the tables, all the object classes, all our features with the relations and topology, so that I can now begin with data entry. Yeah, and we will be done for this exercise. So that's it. Thank you.